Hi everyone, it's Mr. Hamilton here. In this video we're going to look at the academic questions that were in the review section for our Polynomials and Exponents unit. I'm going to start with taking up the last question that was on the review questions, and then I'm going to take up some of the specific homework questions from the textbook. And so the last question is probably one of the most difficult questions in this whole unit. However, once you understand how to do it, I don't think it's going to be as complicated as you might originally think. So let's walk through that together. And I'm actually going to show you there's two ways to approach the question. And so you might find one way is more helpful than others. So we have this almost a rectangle. It's just missing a little corner here. And we are asked to find things to represent the perimeter and the area. And so there it says, recall that the perimeter is the sum of all the lengths around the object. And recall that the area is the length times the width of a rectangle. And so we can break this into what we call a composite figure. And so you've probably dealt with composite figures before. It's literally taking something and splitting it up into one area and then adding it to another area, two rectangles, and we can easily find the area of those rectangles. So that is one way to do it, and I'm going to come back to that in a minute. But I want us to consider first the perimeter. And so the perimeter is walking all the way around. And so the only things we're missing are these two measurements, which makes it a problem. We can't just go ahead and add up everything for the perimeter. However, there's some things that we can do to solve this. We know that this distance here is 16x, and we know that this distance here is 11x. What's the difference between those? Well, the difference between those is 16x minus 11x, or 5x. So the dimension along this side right here is 5x. And we can do a similar thing for this piece, all the way going along here. We can go ahead with that, and we can say, well, I know this long side is 4x plus 4, and then the short side is 3x plus 3. So I have to subtract the short side from the long side. So if I do that, now notice I'm subtracting 3x plus 3. I'm subtracting all of that, so that all needs to be in brackets. If you don't put it in brackets, you don't end up with the right sign on the plus 3 there. It doesn't change the sign to a negative, and you get the wrong answer. So you need to subtract that entire side by putting it in brackets. So 4x plus 4 minus 3x, and then the negative switches the sign on this to minus 3 as well. So minus 3x minus 3. Gathering like terms, 4x minus 3x gives you x, or 1x. 4 minus 3 gives you 1. So this side down here is x plus 1. And so now that I have all the sides all the way around, I can go ahead and add these together. So what's the perimeter? Well, the perimeter, I'm going to go around in a clockwise rotation from 16x, and then I'm going to 3x plus 3 and walk all the way around that way. So 16x plus 3x plus 3. If you keep going, we calculated the next side length to be 5x. We calculated the next side length to be x plus 1. And then we knew the next one to be 11x, and the bottom was 4x plus 4. And then it's just a matter of collecting all the like terms. And if you've collected all the like terms, there are a lot there to collect. But the nice thing is they're all positive, so there's no mixing up of integers here. So 16 plus 3 plus 5 plus 1, don't miss that 1x there, plus 11x plus 4x. So you're going to add all those together. You're going to arrive at 40 x's. And then you have 3, 1, and 4, so 40x plus 8. So that's what you should have found for the perimeter. Now let's look at the area of the object. And this is where we have two different strategies that we can employ. So I'm going to draw this right here in terms of something that's just missing a corner. And as I said before, I could let this be area 1 and let this be area 2. And this is the addition way of doing it. And so if this is area 1 and area 2, we know the dimensions of each of these. We know the dimension of area 1 was 16x on this side. And then we know along the top it was 3x plus 3. And for area 2, we found the dimension there. We calculated that to be x plus 1. And then the side length here was 11x. And so really we're just taking those two dimensions. We're saying the total area is equal to adding those two together. So in the one case, area 1 plus area 2. And so area 1, length times width, it's a rectangle. So length is 16x, width is 3x plus 3. And then for area 2, I have 11x times x plus 1. And you'll notice I wrote the monomial first. I could have written it the other way around. It doesn't matter. But in general, we write the monomial first so we can see the distributive property going in this direction. But the distributive property would still work if we had the 16x after the 3x plus 3, or if we had the 11x after the x plus 1. X plus 11 plus 1. Be clear about that there. All right. So 16x times 3x gives you 48x squared plus 48x plus 11x plus 11x squared rather, because x times x gives you 11x squared, plus 11x. Gathering the x squared terms together gives us 59x squared plus 59x. So that is our total area using the addition method. I told you there were two ways to do this, and you can determine what one's easiest for you. Here is the shape again. And in this case, what I'm going to do is I'm going to draw it all the way around, and then we are going to subtract this corner from it. So the subtraction method is a matter of saying, okay, well, I know my entire width of this whole shape was 4x plus 4, and I know my entire height of this whole shape was 16x, and then I knew this was 5x up here, and this was x plus 1. And so we're going to, in this case, say the total area is equal to the big area, the entire rectangle, minus the corner area. And so the big area, well, the big area is just going to be 16x times 4x plus 4. And the corner area is going to be 5x times x plus 1. And so what we get is 16x times 4x gives you 64x squared. And then you keep expanding that out, you get 64x minus 5x squared minus 5x. And so in this case, you're subtracting that bit off. So you're going to end up at 59x squared minus 59x. And those two answers are the exact same. So you could think about it either way. You could think about it in terms of these composite objects. So it's a composite image, so it's made up of more than one rectangle. Or you could think about it being as a rectangle with a corner chopped out of it. And both of those things are going to give you the exact same answer. So I hope that was helpful. Let's look at a few other questions from the review. I won't spend quite as long as on those other ones, but let's have a look at some of these. On page 174, there's a question about the half-life of carbon. And so C14, you don't need to know anything about how this works except the fact that when something dies, it has a certain amount of carbon-14 in it. And then it decays. We've done a bunch of experiments to know that carbon-14 is half of what it was every 5,700 years. Not necessarily, they haven't spent 5,700 years to do that experiment, but they can say after a couple of years, well, how much is left? Well, it's on track to be halved in 5,700 years. So if you had 50 grams of, so here we have 50 grams of this carbon-14, and then after 5,700 years, it would have 25 grams left. Hence, it's halved. It's half of what it was. So after another 5,700 years has passed, you have half of the 25. So we have 12.5. Go through another 5,700 years, you're going to be at 17,100 years that would have passed, and you would have 6.25, half of 12.5. And if you go through another 5,700 years, you're going to have half of that, which is 3.125. And so what it's trying to get you to do for the expression is it's trying to get you to represent that in terms of 50 times a half to a power. And so if after one half it was, we multiply by half to the power of 1, then now that it's been halved twice, we're multiplying by 1/2 to the power of 2. And now we're halving a third time, so it's 1/2 to the power of 3. And finally, that fourth time we've halved it, we have 1/2 to the power of 4 times 50. And so that's what you're asked to do with that chart. Now part B asks you to construct a graph of the amount of C14 remaining versus time in years. Describe the shape of the graph. So what I've done here is the points that you would actually put on your graph would be something along the lines of the point after 5,700 years, it has 25 remaining, so you're going to have that point. After 2 half-lives, that is going to be 11,400. You would have 12.5. After 3 half-lives, it's going to be 17,100. And you are going to have 6.25, as I already noted. And then after 4 half-lives, it's going to be at a value of 2,200 or 22,800, and you would have about 3.125 is what we noted. So those are the key points that you'd graph on your grid. And then this is the number of years down here. We're always going to put time on the x-axis. So the number of years down here. And this is going to be the amount of C14 remaining. And so you see that the shape of that remaining, you see that the shape of the curve is it gets less steep over time. And it goes down. Clearly it goes down, right? We would expect the carbon-14 levels to go down over time. So that's what's happening, and that's how we can describe the shape of the graph. So then it asks 2 other questions that you can just take the information from the graph for now. By the time you do grade 11 functions, we would learn how to do this algebraically, but for now, we can just take it from the graph. Approximately how much C14 will remain after 20,000 years? So we say, well, 20,000 years is somewhere roughly in here. So it looks like this is going up by 2s, so somewhere around 4 grams. The back of your book says 2.69 grams. They're completely wrong. Not right, okay? Don't go with the back of your book on that one. It's around 4 grams approximately. It then says, how long will it take until only 1 gram of C14 remains? Well, 1 gram remaining, it looks like it's going to occur right about there. And so every 2 is 5,700 years. So it's going to be somewhere about 3,000 years past 22,800, maybe somewhere around 26,000 years from when the C14 first started to decay is when that would be down to 1 gram. And so you can just take those pieces of data from the graph. All right, let's look at a few more questions now and see if we can do those together. So this next one says, simplify the following. So we're at our exponent laws. And the first thing I want us to do here is recognize that any variable without an exponent is like to the power of 1. And so what we have here on the top is we have the product rule. We're going to combine the ones that have the same base. So in the case of the a, we have a base, one a with a power of 1, another a with a power of 3. We're going to add those together. And then we're going to also have a b to the power of 2 and a b to the power of 3. So we're going to add those together. And we're also multiplying 2 times 3. And so I can actually combine those, 2 times 3, to give me 6. On the bottom, so the top was the product rule. On the bottom, we're going to use the power of a power rule. In this case, don't forget that this 4 is like it's to the power of 1. So when we bring the power of a power rule out, we need to make sure that we include the coefficient as well, the 4. So this becomes 4 squared, a squared, b to the 4. We multiply those together. 1 times 2 gives you 4 to the power of 2. A to the power of 1 times 2 gives you a to the power of 2. And b to the power of 2 times 2 gives you b to the 4. So let's just go ahead and write this out as 6a to the 4, b to the 5 divided by 4 squared is 16, a squared b to the 4. And so now we're going to use the quotient rule. The third and final rule that we've learned so far this year is the quotient rule. And so we're going to subtract these exponents, so 4 minus 2, but at the same time we'll also simplify this fraction. So 6 divided by 16 simplifies to 3 over 8. And then 4 minus 2 gives you a to the power of 2. 5 minus 4 gives you b to the power of 1, or just b. And so with those three rules, we've been able to expand out the numerator, expand out the denominator, and then combine the numerator, and then divide those two to get it to something much simpler. All right. 11a says in a hockey tournament, teams are awarded 3 points for a win, 2 points for an overtime win, and 1 point for an overtime loss. Write an expression that describes the number of points a team has. And so this is just getting you to be able to go from words to an equation. So if you haven't done this yet, go ahead and underline the 3 points for a win, 2 points for an overtime win, and 1 point for an overtime loss. And so I'll define the first one for you if you're still stuck with that. But what I'm going to do is I'm going to let W be a win in regulation, so not in overtime. Okay, if you say win in regulation, it means not overtime. And then go ahead and do the other ones and check your answer. You can pause the video and check your answer with me after you write that. So I decided to let W be a win in regulation, not overtime. Let X be an overtime win, and let Y be an overtime loss. The reason for that is I didn't want to use an O or an L, because an O looks like a 0 and an L looks like a 1. So my expression, we get 3 points for the win in regulation without going to overtime. We get 2 points for the win in overtime, and we get 1 point for a loss in overtime. So that expression represents the number of points a team has. 13D now says state the degree of the polynomial, and I hope this is relatively straightforward, but just if it's not, some of us might be saying, well, this is a degree 3 here, this is degree 2, and this is degree 1, so it's degree 6. No, we just look at the largest power, and so this has degree 3. And while we're here, we might as well also note that this is a name to this because it has 3 terms. This is also called a trinomial. 3 terms. So that's just a little aside. All right, 2 last final questions here that we'll look at in this video. It says expand and simplify the following. And so this is one where we have to use the distributive property. We have to use it 3 times. So what we're going to get here is 8d. That's 4 times 2d. That gives us 8d. 4 times negative 5 gives us negative 20. 3 times d squared gives us 3d squared. 3 times negative 3d, negative 9d. Negative 2d times d gives you negative 2d squared. And negative 2d times positive 1 gives you minus 2d. We combine the like terms. There's the d squared terms. That gives me just d squared, or 1d squared. I combine the d terms. Don't forget the signs in front of them. So I'm going to have an 8d minus 9d is negative 1d, minus 2d is negative 3d, and then I'm left with a minus 20. Notice I write the largest power first, followed by the next largest power, followed by the number without any variable. So that's generally the accepted way, always the largest power first. All right, one more. This is the very last question on the review, and it asks you to simplify the following. And so, as I've noted before, if you have brackets inside brackets, you begin by expanding the inside brackets. Expand the inside brackets. So if we expand the inside brackets, we're not going to do anything else yet. We're just going to expand that inside brackets as my pen makes these weird lines on the screen. So 9 minus, and we're going to go negative 2 times k, which is minus 2k, and negative 2 times 3, which is minus 6. Now at this point, you could go negative 3 times each one of these 4 terms, but you can also simplify what's in the brackets, as I'm going to do here. So I'm going to combine the like terms in the brackets. So the 9 minus 6 gives me 3, and the negative 2k plus 5k gives me plus 3k. Now I use the distributive property to finish this off, and I think from here you could probably take it. We get negative 9 minus 9k, so it simplifies quite nicely. So the only reason we have those square brackets is just so that we see those differently than the round brackets, don't get confused by them. hopefully that helps, and hopefully it's a good summary for you of the big problems that people get stuck up on.